Okay, hello everyone, and welcome to question number 13 of the free machine design and materials exam that's offered at engineeringappliedpractice.com. So let's read through the problem statement. A truss is shown in the figure below. Find the force in truss section BD and state whether it is in tension or compression. Find the force in pound force. Okay, so this is just sort of a classic truss problem. And I have the truss sort of written down on this page right here. So let's go over what we're trying to find. What we're trying to find is the force that will be in this truss member BD right here. So we're going to be looking for force BD. That's what we're after. So there's two different commonly taught methods for this. The first would be method of joints. And the second would be method of sections. Now, sort of the advice that I've received when using these is if you're asked to solve for everything, do the method of joints. If you're asked to solve for one specific member, you should use the method of sections. So that's what we're going to use in this solution. So let's get started. I'll erase this. And regardless of which method you use, the first initial step still stands, and that's to find sort of a global equilibrium. And so to that end, let's find that. So what does that mean? We're going to be looking for AX, we're going to be looking for AY, and we're going to be looking for GY. Now, the first thing that I'd like to go over on this is why isn't there a GX? There isn't a GX because this is simply supported. G is on a roller, so there can't be any reaction force in the X direction. A is not on a roller, so you could have an AX in this case. However, if we look at the loading, everything is vertical. So from that, we can automatically just say AX is equal to 0 because there's no forces to sum using Newton's laws in the X direction. So, okay, let's find AY and GY. That's step one. So to that end, let's take a moment about A. We're going to say that counterclockwise is a positive direction. So we have the first force, which is 5,000. It's negative. And let's multiply that by the distance, which is 10. We have the next force, which is 1,000. Again, negative, times the distance, which is 20. And then the last force we have is a positive one. It would be GY. So GY is going to act in sort of this direction up. And you can think of GY as pushing the whole force, the whole truss member up. It's sort of your reaction force. So we'll say GY is pushing sort of in this counterclockwise direction, and the distance is 30. And we're using Newton's laws, and this is a static truss, it's not moving. So what can we say? We can say that all of these moments must be equal to 0. There is no angular acceleration in this problem. Okay, so we're after GY. Let's solve for GY. GY is equal to 5,000 times 10 plus 1,000 times 20 all over 30, which comes out to 2,333. Okay, now we want to solve for AY. Again, using Newton's laws, we say that the sum of forces in the y direction, we're going to say up is positive. We can say that there's AY plus GY. Let me label AY for y'all. Right here is AY. So AY plus GY, what are the forces acting down is 5,000 and 1,000, so minus 5,000. minus 1,000. Again, is there any acceleration in this problem? No, so we can set all of these equal to 0. And what I mean by that is Newton's second law. If anyone needs a refresher, says that force is equal to mass times acceleration. In this case, acceleration is 0, so the net force be equal to 0. And so all we're doing is summing this net force and setting it equal to 0. Let me erase this. We'll continue. So we want to solve for AY. AY is equal to 6,000 minus 23,333, which is equal to 366. I'll put 7. I don't like 3 6s. Okay, so let's continue with this. We have now GY and AY solved for. So we have gotten sort of this global equilibrium for this set of trusses. So let me go to the next page, and let's see if I can paste this truss so we still have it as reference. Now we know that AY is equal to 3,667 and GY is equal to 2,333. So that's what we've solved for so far. Now we need to do method of sections. Method of sections. So for the method of sections, we can cut through three truss members in total. Looking at this problem, what we're after is BD. So I say let's cut through this section like so. So how does that look practically? We copy it down like this. This would be A. This would be B. I'm going to draw this member in here. The rest we cut through. So let's draw AY first. We have 3, 6, 6, 7. Moving up right here. We have, doing a different color here. We have FAC here. We have FBC here. And then we have FBD. And what are we solving for in this problem is FBD. Okay, so this is where you really have to try to utilize your time to the best of your ability, because the best method to use from here just to sort of solve this problem is to take a moment. What do we know about moments is that you can't produce a moment if a force goes through the point which you're taking a moment. So if a force line of action is going through your point, so I'm going to say point C, then it doesn't produce a moment. So practically, C is a really good spot in this problem to take a moment. So let's go ahead and do that. So we say sum of moments about point C, counterclockwise is going to be positive. We're going to say that FBD times some distance. Okay, what is this distance? I suppose we're going to have to solve it. So we know this is 60 degrees right here. And we know that if we took half the distance of 10, that this is 5. So let's just draw a simple triangle right here. We have 5, we have 60, we want to know, I'll put H right here. So this looks like a problem for tangent. So SOHCAHTOA, tangent is equal to opposite over adjacent. So H is equal to 5 tangent 60. Which is equal to 8.66. Okay, so circling back to here, we calculated this to get distance that FBD acts. So a moment is a perpendicular force and the distance. So in this case, the distance is that 8.66. So that's positive. And then this other force, AY, is going to be in the negative direction. So 3,667 times, how far away is it? It's 10. Again, we're going to set this equal to 0 because there's no acceleration. So let's solve for FBD now. It's equal to 3,667 times 10 divided by 8.66. Fix the 10 times 10. And that's going to come out to 4,233 pound force. No, I haven't been labeling that. So now the last thing to do is to tell if this is in compression or tension. When you are doing the method of sections, I think this is just something good to memorize. If the force, and I'm looking right here for all of you, if the force is pointed towards the joint, then it's in compression. If the force is pointing away, then it's in tension. So in this case, the problem is in compression. So going back to our answer selections, we can see that it is option A. If you have any questions or comments, leave them below.